Hi, welcome back to maths class. I completed exercise 1A in previous video. Let's start the continuation of those. Inverse function. If f maps a to b, then the relation f inverse is equals to b comma a comma b belongs to f is a function from b to a and is called inverse of a. Let me explain one example. If a is equals to 1 comma 2 comma 3, b equal to a comma b comma c, then f is equals to 1 to c, 2 to b, 3 comma a is a bijunction from a to b, and f inverse is equals to a comma 3, b comma 2, c comma 1 is a bijunction from b to a. Take two sets a and b. This is set A, this is set B. F is a function from A to B. Set A elements are 1, 2, 3. Set B elements are A, B, C. F is a function from A to B. So 1 to C, 2 to B, 3 to A. Bijunction means it satisfies both injection and surjunction. So first check it is injection or not. So different elements have different images in codomain. So it is a injection. It is surjunction. Yes. In codomain every element have corresponding image in domain. Okay, codomain is equals to range. It is injection. Then it is a bijective function. It is injection. It is surjunction. It is a surjunction. And it surjunction means codomain equals to range. It satisfies injection, surjunction. Then it is a bijection. It is a bijunction. Next, F inverse from B to A. Take two sets. This is set B, this is set A. F inverse is a function from B to A. Set B elements are A, B, C. A, B, C. Set A elements are 1, 2, 3. 1, 2, 3. F inverse A to 3. A to 3. B to 2. C to 1. It is bijunction or not? First you can check it is injection. Yes. Different elements in codomain have different images in different elements in domain have different images in codomain. Okay, it is injection. It is injection. It is surjunction. Yes. In codomain each element have corresponding image in domain. Codomain is equals to range. Codomain is equals to range. What are codomain elements? 1, 2, 3. 1, 2, 3. Range elements 1, 2, 3. So it is a surjunction. It is a surjunction. It satisfies injection and surjunction. Then F inverse is a bijection. F inverse is a bijunction from B to A. It is a inverse function. See the next definition. Composite function. If F maps A to B, G maps B to C, then the relation A comma G of F of A is A such that A belongs to A, called composite of Z with F and is denoted by G circle F. Let me explain example. Take 3 sets. This is set A, this is set B, this is set C. F is function from A to B. G is function from B to C. Set A elements are 1, 2, 3. Set B elements are A, B, C. Set C elements are X, Y. I am mapping like this. A to X, B to Y, C to Y. This is, here G is mapping from B to C. This is G circle F. G circle F maps A to C. F of 1 is equals to A. Image of 1 is A. Image of 1 A. Image of 2 B. Image of 2 B. F of 3 is equals to C. Image of 3 C. Again, G of A is equals to X. Image of A X. G of B is equals to Y. Image of B Y. G of C equal to Y. Image of C Y. This is F maps A to B. This is G maps B to C. Then G circle F. G circle F maps A to C. Now see. G circle F of 1 equals to G of F of 1. Remove the circle and put the square bracket. Here G of F of 1 is A. G of A. G of A is equals to X. Image of A is equals to X. G circle F of 2 equals to G of F of 2. F of 2 equals to B. G of 2. F of 2 equals to B. G of B equals to Y. G of B equals to Y. G circle F of 3. G circle F of 3 equals to G of F of 3. F of 3 is equals to C. G of C. G of C equals to Y. G of C is equals to Y. This is G circle F to G circle F maps A to C. This is called composite. This is called composite function. Okay. See the next one. Theorems. Most important theorems. In this chapter there are 4 theorems. Out of these 4 theorems, so one theorem definitely going to come in the exam. These 4 theorems are very important. This is the first one. Let F maps A to B, G maps B to C be a bijunction. Then G circle F maps A to C is a bijunction. We have to prove G circle F maps A to C is a bijunction. Bijunction means it satisfies injunction and surjunction. Proof. let us prove that G circle A to C is an injection function. Injection function means f of x1 is equals to f of x2. To solve f of x1 is equals to x2 to get x1 is equals to x2, and g of x is equals to g of x2, x1 equals to x2. This is the condition for injection. Let us consider a1 comma a2 belongs to A. G circle f of a1 is equal to G circle of a2. Like this, f of x1 is equals to f of x2. Remove the circle and add square bracket. G of f of a1 equals to g of f of a2. Here f of a1 is a1, g of a1 equals g of a2. F of x1 is equals to f of x2 is x1 equals to x2, like this. Then g of a1 is equals to g of a2 is a1 equal to a2. Therefore, G circle F map A to C is an injection. Next, we have to prove G circle F maps A to C is a surjunction. Let us prove that G circle F maps A to C is a surjunction. Let us consider A belongs to A, B belongs to B, and C belongs to C. Take 3 sets. This is set A, this is set B, this is set C. A belongs to A means A is the element of set A. B belongs to B means B is the element of set B. C belongs to C, C is the element of set C. F is a function from A to B. G is a function from B to C. This is G circle F. G circle F maps A to C. What is subjunction condition? F of x is equals to y. We have to prove f of x is equals to y. Given f maps A to B is a surjunction. F of A equals to B. Image of A equals to B. F maps A to B. And G maps B to C is a surjunction. B to C. Image of B is C. Then G of B equals to C. C equal to G of B. B is equal to what? F of A. That equals to G of F of A. Remove the square bracket and add circle. G circle F of A. Therefore, G circle F of A equals to C. Image of A is equals to C. G circle F maps A to C. Therefore, G circle F maps A to C is a surjunction. G circle F maps A to C is a injection and it is a surjunction. Then it is a bijunction. Therefore, G circle F maps A to C is a bijunction. First theorem is completed. See the next theorem. Second theorem, let F maps A to B, G maps B to C be bijunctions, then G circle F all inverse is equals to F inverse circle G inverse. We need to prove that these two are equal and we also need to prove that their domain is the same. ఇవి రెండు ఈక్వల్ అని ప్రూవ్ చేయాలి, వీటి యొక్క డొమైన్స్ సేమ్ అని ప్రూవ్ చేయాలి. ఓకే, ప్రూఫ్. Given F maps A to B, G maps B to C are bijunction. Already they are given. F and G functions are bijunction. So F maps A to B is a bijunction, G maps B to C is a bijunction. Take three sets. This is set A, this is set B, this is set C. F is a function from A to B, G is a function from B to C. Small a is the element of set A, small b is the element of set B, small c is the element of set C. G circle F A to C. These two are bijunctions, then G circle F is also bijunction. Therefore, G circle F maps A to C is also bijunction. Function F, function G ఇవి రెండు bijunction అయినప్పుడు G circle F is also a bijective function. Therefore, G circle F all inverse maps C to A. G circle F is a bijunction, then inverse of this one is also bijunction. C to A is also bijunction. G circle F అనేది bijunction అయితే దాని యొక్క ఇన్వర్స్ ఫంక్షన్ కూడా bijunction అవుతుంది. C F inverse map B to A, F maps A to B, F inverse B to A. G maps B to C. G inverse C to A. Sorry. G inverse C to B. These two are bijunctions. The inverse of these functions are bijunctions. You can see here. Codomain of this function and domain of this function, these two are equal? No. Here set C, here set A. The comparison is not correct. Then G inverse maps C to B, F inverse maps B to A. Codomain of this function, domain of this function, these two are equal. ఫస్ట్ ఫంక్షన్లో కోడొమైన్, సెకండ్ ఫంక్షన్లో డొమైన్ రెండు ఈక్వల్ ఉండాలి. ఇక్కడ ఏ ఉంది, ఇక్కడ సి సెట్ ఉంది. సో ఇది కరెక్ట్ కాదు. దిస్ ఈజ్ నాట్ కరెక్ట్. జీ ఫంక్షన్లో బి కోడొమైన్ ఉంది, ఎఫ్ ఫంక్షన్లో బి ఉంది. కంపారిజన్ సేమ్ ఉంది కదా. ఇక్కడ డొమైన్ ఇక్కడ కోడొమైన్, ఇక్కడ డొమైన్ రెండు ఈక్వల్ ఉన్నాయి. ఆర్ బైజంక్షన్స్. Bijunctions. Therefore, F inverse circle G inverse maps C to A is also bijunction. Take 3 sets. C, this is set C, this is set B, this is set A. G inverse C to B. G inverse is a function from C to B. F inverse is a function from B to A. So small c is the element of set A, small b is the element of set B, small a is the element of set A. This is F inverse circle G inverse from C to A. F inverse circle G inverse map C to A is also bijunction. We have to prove G circle F whole inverse C to A is also bijunction. F inverse circle G inverse map C to A is also bijunction. ఇవి రెండు కూడా ఈక్వల్ అని ప్రూవ్ చేసాం కదా. These two are equal. Now we have to prove the domain is the same. Their domain same. ఈ రెండిటి యొక్క డొమైన్ సేమ్ అని ప్రూవ్ చేయాలి. Here G circle F whole inverse and F inverse circle G inverse are defined on the same domain. Same domain C. Let small a belongs to capital A, small b belongs to B, and small c belongs to C. F maps A to B implies f of A is equals to B. F is a function from A to B. Image of A is B. F of A is equals to B implies F inverse of B equals to A. F inverse from B to A, image of B is A. G maps B to C implies G of B is equals to C. G is a function from B to C. Image of B is C. G inverse of C equals to B. G inverse from C to B. C is the image of C is B. Image of C is B. C equals to, I am taking this one, C equals to G of B, that equals to, B equals to F of A. G of F of A, that equals to, remove the square bracket and add circle, G circle F of A. C equals to G circle F of A. G circle F of A, I am taking this side. G circle F whole inverse equals, whole inverse of A equals to C. This is equation 1. Next, F inverse circle J inverse of C equals to F inverse of, remove the circle and add square, G inverse of C, that equals to F inverse of, G inverse of C is B, F inverse of B. F inverse of B equals to A. Therefore, F inverse circle J inverse of C equals to A. This is equation 2. Sorry, this come this side, this is here C, here A. G circle F, I am taking this side, that is G circle F whole inverse of C equals to A. From equation 1, from from 1 and 2, therefore G circle F whole inverse equals to F inverse circle G inverse. Both are same. Both have same domain. From equation 1 and 2. This is the second theorem. So please share, subscribe for more videos. If you have any doubt, please comment.